When Darwin placed a blindfold on a growing coleoptile, he observed that the plant no longer grew toward the light. This suggested that something in the tip of the coleoptile was responsible for this directed growth. Other experiments demonstrated that even when the tip is removed and a layer of agar placed between the tip and the base, the plant still grows toward the light. This suggests that the light-sensitive signal can travel through a permeable barrier, directing the plant's growth. If the severed tip is replaced on the growing shoot so that it covers only half of the exposed cut, the side touching the tip grows faster than the other side, causing the coleoptile to curve, even in the dark. This demonstrates that the signal does not migrate across the shoot. The Dutch botanist Frits W. Wendt wanted to find out if he could isolate this signal from the coleoptile tips. First, he removed the tips of oat plant coleoptiles. Next, he placed the detached tip onto a block of agar. After 1 hour, he discarded the tip and positioned the agar on decapitated coleoptiles in such a way that the block only covered half the exposed cut. What do you suppose happened when Wendt placed the agar back on the decapitated coleoptile? Click on the coleoptile on the right that represents the likely result of this experiment. When Wendt placed the agar block on one side of the decapitated shoot, the shoot curved away from the agar as it grew. This demonstrated that some kind of hormonal signal had diffused into the agar from the coleoptile tips. This hormone had then diffused into the growing coleoptile. The hormone, subsequently called auxin, caused the growing plant to curve, even in the absence of light. Wendt's experiment represented the first time that anyone had isolated a hormone from plants.